Welcome to all in this another video lecture. So in the last lecture we discussed about the Euclidean graphs, and in Euclidean graphs we discussed about the Euler paths and Euler circuits, and we look for the difference between path and circuit. And in this lecture I am going to cover this topic, Hamiltonian graphs, and the two theorems based on this concept of Hamiltonian graphs, right? Dirac's theorems and Orr's theorem, and then I will discuss the Travis-Smith problem, right? So first of all, let's look for this Hamiltonian graphs, right? Okay. So what is in Hamiltonian graph or Hamiltonian circuit or path, right? So first of all, the Hamiltonian path, okay? So in Hamiltonian Hamilton path, right? Hamilton paths, right? So Hamilton path is a simple path, right? A simple path. You know what is mean by path, right? A simple path in a graph, right? In a graph, right? G, right? That passes through every vertex exactly once, right? Exactly once is called a Hamiltonian path, right? Okay, so this is exactly once, right? So let's take an example, right? The example is this. Example of this is A, we have here B, right? A to B, and then we have B to C, then we have this path D, and then we have this path B, right? Okay, now in this what we have to do, we have to find a path. If we can find a path that cover all the vertices exactly once means you have not to repeat any of the vertex, okay, or you don't have to use the vertex twice, okay. It's only access only once. So let's start from here. So here A, then we go to B, then we go to D, and then we go to C. So in that way, right, in that way we have covered all the vertex, right? So this is a Hamilton path, sorry, Hamilton path, right? Okay, so, and if you have watched my earlier video on Euler path, so there is a difference between these two paths, a very minor difference, that in Euler path we cover all the edges, and in Hamilton path we cover all the vertex. So there is only one difference in that. Again I repeat it, in Euler path we traverse or we cover all the edges in a graph whenever in a Hamilton pass we cover all the vertex only exactly once. Okay, so there is a difference. Now it's very easy, right? So now Hamilton circuit, right? So what is Hamilton circuit? So as I have already discussed in circuit, the when the initial and ending vertex are same, means if I start from this point, I end at this point, right? So this is like a circuit, right? Okay, now अगर आपको सर्किट नहीं पता है तो सर्किट जैसे ये फॉर्मूला बन रहा है इसमें सर्किट होते हैं वैसे ही, तो सर्किट इज लाइक मीन्स द इनिशियल एंड initial point and ending point are same. So that's the circuit. Okay, right. Now Hamilton circuit. So Hamilton circuit is a simple circuit, is a simple circuit, right? It is a simple circuit. It is a simple circuit in graph G, right? In G that passes through every vertex. Okay, that passes through every vertex exactly once. Every vertex exactly once. The definition is same, right? The definition is same for the path and circuit, but this term is only this word circuit. Here I have this word is path in Hamilton path, right? So circuit is when the initial and ending point are the same. So that's circuit, and the condition is that you have to cover all the vertex only at once or exactly once. You don't need to repeat the vertex, right? So here I have this this is a graph, right? Here A, B, right? So we have this graph. Okay, now this is the graph, right? A, B, C, D and E. So find if it has a Hamilton circuit, right? Hamilton circuit, right? So this is your graph G, right? So the Hamilton circuit. So Hamilton circuit is what? It's a circuit that passes through every vertex exactly once. So let's start with A. So start with A. So we go to B, so B to C, then C to D, D to E, and then E to A. So it's very simple. So A, B, C, D, E, A. Okay. So if they ask in your exams about Hamilton circuit example, so you can give this example. So here you start with A and you end with A, right? So it forms a circuit. Okay, and it covering each and every vertex. Okay, so this is the example for Hamilton circuit. Now let's discuss about the two theorems that are in your syllabus, right? The theorems are, the first theorem is this theorem is Dirac's theorem, right? Dirac's theorem. Okay, it is if G is a simple graph, right? If G is a simple graph, simple graph with n vertices, with n vertices, right, with n vertices, with n is greater than equal to 3, मीन्स जब नंबर ऑफ वर्टिसेस किसी भी सिंपल ग्राफ में 3 या 3 से ज़्यादा हों, देन अगर ऐसा है, देन सच दैट the degree of every vertex, right, the degree of every vertex, the degree of every vertex, right, in G is at least n by 2. तो अगर ऐसा है, then we say that the G has Hamilton circuit. G has Hamilton circuit, right? This is your first year, as is given in your syllabus, right? So whenever there is a simple graph with some vertices but greater than or equal to 3, then the degree of every vertex in G is at least n by 2. तो हर एक वर्टेक्स की जो डिग्री है वो कितनी होगी, n by 2. अगर हमारे पास 4 वर्टेक्स हैं, ठीक है, तो कम से कम हर एक वर्टेक्स की डिग्री 2 होगी. n by 2 मीन्स n नंबर ऑफ वर्टिसेस, n by 2, 4 by 2 विल बी 2. तो वो क्या होगा, एक हैमिल्टन सर्किट होगा. तो ये जो थ्योरम है वो हैमिल्टन सर्किट के लिए है. फॉर एग्जांपल हम ये ले सकते हैं, बहुत अभी हमने किया भी एग्जांपल, और वही सेम एग्जांपल है, और मतलब उसको हम थोड़ा ये ऐसे लिखना है, ए बी सी डी, ठीक है, ठीक है. और यहाँ आप देखो तो ये एक हैमिल्टन सर्किट है. हैमिल्टन सर्किट क्यों है, क्योंकि वी कैन कवर ऑल द वर्टेक्स विदाउट रिपीटिंग और विद एग्जैक्टली वंस, है ना. सो हम A, B, D, C, ठीक है. So let's find if this is true, no, this theorem is true. So n is greater than 3. So n is the number of vertex. N is what is n? N is the number of vertex. So here in this graph, let's say this graph is G. In this graph, the number of vertex is 4, A, B, C, D, right? Now it says the degree of every vertex. The degree of every vertex in G is at least n by 2. कम से कम हाफ है नंबर ऑफ वर्टिसेस के. सो डिग्री ऑफ ए कितनी है, 2. डिग्री ऑफ बी इज 2. डिग्री ऑफ सी इज 2. डिग्री ऑफ डी इज 2. बिकॉज there are 2 adjacent edges, or there are 2 adjacent vertices. Okay, so this is 2. So degree of every vertex is n by 2, means the number of vertices is 4, so 4 by 2 is 2. So here, so this is the proof for this direct theorem, right? Okay. Now the second theorem, which is your as I show you your syllabus in the first in the starting of this lecture. This is Dirac's theorem, this is Ohm's theorem. So let's discuss about Ohm's theorem. Now Ohm's theorem is okay. What is Ohm's theorem, right? Ohm's theorem is your, if G is a simple graph, right, if G is a simple graph, right, G is a simple graph, G is a simple graph with n vertices, and with the same condition which was earlier in the Dirac's theorem, which was n is greater than or equal to 3, right? right? So the two theorems are based on this concept when n is greater than equal to 3, and it says that such that degree of u plus degree of v is greater than equal to n, is greater than equal to n for every pair of adjacent for every pair of non-adjacent vertices u and v, right? U and v and g, and it is 4 also. Then we can say that G has a Hamilton circuit. तो ओर्स थ्योरम व्हाट इट सेज, ओर्स थ्योरम कहती है कि अगर G एक ग्राफ है जो दिया हुआ है आपको, सिंपल ग्राफ है, कंडीशन क्या है कि नंबर ऑफ वर्टिसेस मस्ट बी ग्रेटर देन इक्वल टू 3, राइट? या तो 3 या 3 से ज़्यादा हो। अगर ऐसा है तो वहाँ पर जो नॉन एडजेसेंट वर्टिसेस हैं, नॉन एडजेसेंट वर्टिसेस, कोई भी नॉन एडजेसेंट वर्टिसेस, उनकी जो डिग्री है ना, उनकी डिग्री है, अगर उनको ऐड करें it will be greater than equal to n. So for example that means this page, right, at end. So for example, so I write this equation for you, that two adjacent non-adjacent vertices, degree of u and degree of v, right, it is greater than n, right? This is the theorem. Yeah? For every pair where u and v are vertices, u and v are what type of vertices? Non-adjacent vertices. And you know that what is adjacent, so this is the opposite of the non-adjacent to the adjacent, right? So non-adjacent vertex. So let's take that example, right, that we previously saw in the when we proved the Dirac theorem, right? So let's say A, B, C, D. So we have these 4 vertices. So the condition is for n is greater than or equal to 3, right? And n is 4 in this case, because n is nothing but the number of vertex, right? Number of vertex or number of vertices, right? So in this graph, so it is okay. So first this simple graph is okay because it has n vertices such that n is greater than or equal to 3. Now find out the degrees of two non-adjacent vertex, right? So to prove that, right? So this vertex A, so these are the adjacent vertices to this A, because A is adjacent to B and A is adjacent to C. So the two non-adjacents are A and C and B and D. So we can take any of the pair. So let's take the pair of A and D. A and D. So find out the degree. So degree of A plus degree of D. Degree of A, degree of D. It must be greater than n, because A and D are both non-adjacent vertices. So for that, to prove this theorem, we have taken A and D because these two are non-adjacent vertex. ठीक है? और अब हम इनकी डिग्री फाइंड करें तो डिग्री ऑफ A is 2 because the two edges here 2 plus 2. Degree of D is 2, right? Because D there are again 2 edges, so degree of 2, right? So now this is 4, right? So greater than or equal to n is 4, right? N is 4. Two term vertex. So here 4 is greater than or equal to 4. So this is true. So this is true. That means we have proved that this Ohl's theorem, right? It is correct, and it says that yeah, if this is the case in any of the simple graph, that the degree of two non-adjacent vertices are greater than or equal to number of vertices, which is n, will be a Hamilton circuit. Will be a Hamilton circuit. So because we have taken the same example, so this is a circuit, because if I start with A, then B, then D, then C, and then A. So it is a circuit. So this is proved, right? If you take another example in this, so you can also take any of the examples where n is greater than or equal to 3, right? Okay, and just find out, right? Okay, and if you have any doubt, you can let me know about the doubts of about the doubts, right? So this is your Hamilton. Complete your Hamilton graphs, Hamilton circuit, Hamilton path, and along with the two theorems which are Dirac and Orr's theorem, right? Okay, so you can do some of the questions based on this. I think that are given in your booklet, right? Okay, now discuss one more concepts that is very much important as in exam point of view, which is that this is now you know what is the complete graph, right? What is the complete graph? So it has been asked, right, that in one of the exams, that show that or prove that, right? So that Kn, right? Kn has a Hamilton circuit. Hamilton circuit whenever n is greater than 3. तो अभी हमने देखा ये दोनों थ्योरम्स को, जो कि दोनों थ्योरम्स n ग्रेटर देन इक्वल टू 3 के लिए थी, ठीक है? और ये this question says that Kn is what? It is your complete graph, right? And you know the definition of complete graph, right? Such graph that has all the edges between all the vertices, right? So Kn has a Hamilton circuit whenever n is greater than 3, right? So we can prove it, right? We can prove it. Let's say for n is equal to 3, draw a Hamilton circuit. Hamilton circuit is this, right? So this is A, B, and C, right? Hamilton, okay, this is a simple graph, right? And this is a complete graph, actually, complete graph. Why complete? Because it has all the edges between each and every vertex, A to B, A to C, B to A, B to C, and then C has A to B. So this is the complete graph, and this is your K3 graph. Okay, so for K3 it has an Hamilton circuit, right? Okay, because if we start with A, we will end with A to C, then C to B, then B to A. So we will end at A, right? So this is your proof. You can also prove it for K4, right? K4 we have already proved that, because this is the K4 example, right? No, this is not K4 example. This is not complete graph, because there is no edge between A to D. So let's take an example for K4. K4 is your complete graph, right? Your complete graph. So this is for K4 when number of vertices are 4, right? Number of vertices are 4. So this is not a complete graph, because if I write A, B, C, D, because there is no edge between B to C and there is no edge between A to D. So let's do it, right? So this is your complete graph, and it says that it has a circuit, right? It has a circuit. It has circuit because when you start with A, you go to B, you go to D, you go to C, right? So we can say that it has a circuit A, comma B, comma D, comma C, right? And then C to A, right? So it has a circuit, right? And so for that we have proved that for 3 it is true, for 4 is true. You can also try it for 5, right? But if you don't know about the type of graphs or don't know the basic concept, paths, circuits and complete graphs, so please do watch the previous videos in the series. It will be helpful for you. Thank you. Thanks for watching. Right.